The next step is to test our assembly so far. So we'll need all our components. We'll need the Pico and all of its connections. We'll need 4 of these telephone wires, one to connect to each one of the 4 components. And we'll need a USB data cable to connect the Pico to a computer. So I'll just show the basic connections at this point and how to set up for the test, but the other piece that's really important will be the actual running of the assembly test program. So just start by taking this apart. Get these 4 wires separated. And it's really pretty straightforward. You're going to connect each component to its matching connector on the Pico. So I'll put one end into the left proximity sensor, the other end into the left RJ11 jack on the Pico. I just have a big space to work to do this piece because everything is going to take up space. Repeat for the left buzzer, and the buzzers are completely interchangeable, so it doesn't matter which one's on which side. But for the purpose of the test, keep the left buzzer kind of on your left side. Attach it to the left buzzer jack on the Pico. I'll do the same for the right buzzer. To the right buzzer jack on the Pico. And the right sensor connected as well. Finally, I'll take our data cable, our USB data cable, and if it's just a charging cable, it won't work for this purpose, but you can easily pick up a data cable instead. We'll just go ahead and plug it in here on one side, the other end plugs into your computer. And we'll be working with a potentiometer as well. So the assembly test will test both the proximity sensors. It'll test both the buzzers. It'll test the potentiometer. Probably the thing that's most important here as far as organizing this space, which I won't be able to show you because I can't get my camera back far enough to show you something like this. But when testing the the proximity sensors, and these wires are stiff enough that they kind of make it a little difficult. What I want to do is I want to put the sensors down. Please ignore these wires. And let me take them off for now, just so I can demonstrate about the wires being a problem. We'll put both proximity sensors down, with this part down, and separate it. Pull all this out of the way. Down and separated, and with the wires coming out. And I want to put something solid between them. And I just use a box of filament, printer filament. How can I do this here? Show this to you. So I'm going to put this box between them so that the signal can bounce off of the box and back to the sensor. And this is just a way to do it sort of in a easily controlled way. Put the box or whatever solid object between them, something that can stand up reliably. Let's get these guys on screen. And what I want to do is I want to put each sensor, switching over to imperial units, I want to put each sensor at least 4 inches from the solid object. So this is 4 inches here. It's a little hard to see with the box in the way, but that's 4 inches. I drop the box in place. Same here. I want this guy to be about 4 inches away. The measurements get a little bit unreliable once the sensor is closer than 3 inches from a solid surface. So put them about 4 inches away. It doesn't have to be exact. It's fun to kind of see how accurate the sensors are by actually measuring the distance. But you need a nice solid object that can that the signal can bounce off of. You can't use something soft because they don't work reliably against a soft object. So set your sensors up like this at approximately 4 inches. You know, could be a little bit larger, but you also don't want the signal to be getting wider than the object you're blocking it with. And then run the test. And each piece of the test involves different things. First, you can test the sensors, then you'll test the potentiometer. And all you do with the potentiometer, get back over. All you'll do with the potentiometer is twist the barrel on the potentiometer counterclockwise, and watch the number go to 0, and then turn it clockwise and watch the number go to 55. With the buzzers, I've got this all tangled up now, but you just keep the buzzers in proper orientation, so the left buzzer's on your left, the right buzzer's on your right, and then step through first playing a tone on the left buzzer and then playing a tone on the right buzzer, and ensuring that you're hearing the sounds coming out. If any of those tests doesn't behave as you would expect, the thing you do to figure out what's going on is just check all your connections for that particular component. Is it nicely seated here? Did you end up capturing a ton of insulation and therefore you don't have a connection? Test the component, or take apart the component again and make sure that your wiring matches what you recorded in these tables, and match and check that these wires have all been connected properly. But this is a good way to get confidence that your assembly up to this point has worked properly, and this is the hardest part anyway. Okay, so I've launched Thonny, and I've loaded the assembly test Python program. And to my side here, I've got the equipment set up as I described earlier in this video. So what I'll do now is, first thing I'm just going to do is click on the stop button to kind of get everything kind of to an initial state, predictable state, and then I'll press the run button. And this is what the test looks like. You can test the potentiometer, the proximity sensors, or the buzzers. You can do them in any order. You can do them at any time. Now is a good time when we've basically assembled a lot of the wiring. And you place the cursor here, click here in the shell pane, click here, and then type a number. So the first thing I'm going to do is test the potentiometer, just because it's first in the list. I'll click 1 and press enter. It says turn the barrel of the potentiometer fully counterclockwise to check that this number down here says 0, and fully clockwise to check that it says 55, and press enter when you're done. So I'll grab the potentiometer and I'll turn it, let me turn it clockwise first, up to 55 all the way, so it's stopped at this point, and I'll turn it all the way counterclockwise, and it should say 0, and it does. I can stop somewhere in the middle just to see that it, by turning it one way or the other, I can increase or decrease this number. That's the threshold for when the proximity sensors make the buzzers beep. All right, so that test is over. I'll press enter, and I get the menu again. I'll test the proximity sensors next. That's a 2. Enter. And I'll see each one is now reporting the distance it sees between itself and the filament box. And I'm just going to move the right sensor now just to see. I'm going to move it back a little bit, see if the number increases. It is. I'll move it forward. And when I get down to about a 3, the numbers won't be too predictable anymore. So it's doing pretty well. By moving it closer and the numbers getting bigger. So it just says that inside of 3, don't trust the number. Let me move the left one in a little bit and move it back. So everything is behaving as expected. I'll press enter, finish that test. And last, I'm going to test the buzzers. 3, enter. And what it's going to do is it's going to play 5 tones from the left buzzer, then it'll be a little bit lower frequency or a lower tone, and then it'll play 5 notes from the right buzzer. And if I'm real quiet, you may be able to hear it happen. And when it comes out of the right buzzer, it'll be a little bit higher tone. All right. And then I'll press 0 to leave because everything's working fine. What can I say about the buzzers? I was going to say something, but I can't think of what it is right now. Oh yeah, if for example any of these didn't match left versus right, well then you can check to see if you've connected the phone cables backwards or something like that.